Okay, thank you everyone, for staying tuned to join us in this session. We know that, the whole event has been quite long and intense, so props to all of the attendees here to this presentation to bear with us so that we can present to you guys what we have been working on in our work stream. We try to make, this type of catchy title, just naming it cleaning IT hardware for peak immersion cooling and performance operation, the final deep, right? What's going to be seen. As I was mentioning before, I am Romà Suris Valls. I am with Submer, liquid cooling solutions provider. And alongside with me is...
I'm JanElsa Carty again. I take care of our shell immersion cooling fluids that are based on Shell's gas to liquids technology.
So we were going to start with this presentation, knowing that we are leading the future for AI with, an AI-generated image on how to introduce the topic on why would it be important to develop these guidelines for cleaning these immersion cooling fluids. I know that the architecture of the system might not make the most sense, but essentially, if we look when servers would come out from these immersion cooling systems or these immersion cooling tanks, they will not come out dry, right? They will have a lot of remnant dielectric fluid linked or attached still to the system, trapped inside the connectors, also dripping on the heat sinks and so on. If this remnant fluid is not treated properly, those remnant of milliliters of the fluid could potentially cause serious downstream risks. And hopefully, we will be able to convey this message to you guys to see how important having a well-thought strategy for cleaning out your servers after their end of life, how important that would be. So essentially, one of the key messages from a lot of talks here in OCP Global Summit has been the rapid adoption of different liquid cooling technologies. Here we're going to be focusing mainly on immersion cooling technologies, which is essentially rapidly expanding as one of the preferred solutions for high efficiency in cooling IT servers. But while the industry has focused on high-density compute, on adoption and implementation of these type of technologies, it has been lacking a little bit on what will happen with this IT hardware when it comes to its end of life, right? So these systems that we are going to be designing today and what to do with them once they are reaching this end of life point will be essentially shaping the standard for tomorrow, right? So the earlier that we tackle any potential issue, the better. And this comes, and this is going to be familiar to some of you. Thanks, Rolf, first of all, for providing with some of the insightful data on why would be cleaning of importance or relevance. We are forecasting a huge increase in market growth size for data center industry, right? This is going to be also seen across multiple different technologies for cooling this IT hardware. Here we can see highlighted in green area what's the projected percentage of new deployments that are going to be considering this type of liquid cooling technologies, whether it's traditional immersion cooling technology or hybrid immersion cooling technology. That is projecting these about 30% of new deployments having or using these new types of technologies. So if we want to use this type of technology at scale, the adoption of these immersion cooling technologies, thousands of servers will start to be retired every single year after adoption when its end of life comes. So without standardized cleaning protocols, operators, vendors, and logistics providers will be facing certain risks. What is the hidden problems that poor cleaning or non-existing cleaning of this IT hardware could be facing? This residual fluid might be looking harmless, right? But during the shipping, it might interfere with some warranty or legislation types of regulations around shipping. Let's put it as an example, RMA purposes. If something goes wrong with the IT hardware, it needs to be shipped back to the manufacturer. Some regulatory compliance bodies see any single type of container containing fluids as a fluid container, and that automatically classifies them as for more stringent types of legislations or scrutiny that could result in legal liability, shipment, and rejection or seizure of the packages that are being shipped, which will ultimately have a potential financial or operational impact due to the operational delays associated with the seizure of these packages, right? So what might work in the lab scale, in POC type of levels, or where small types of deployments might not work or might not be scalable at the mass scale data center scenario. So in this case, removing these fluids, we need these consistent, efficient, and safe cleaning protocols that could be potentially scaled regardless of how big the deployment is. So different players will have different stake, right? Data centers will want safe, low cost, and turnaround or wrapped around cleaning methodologies so that their processes are as efficient as they can be to maximize the uptime of the servers. OEMs will need assurance that any potential part that is returned to them is not going to be contaminated or potentially blocked in customs for like not being able to go by these regulatory processes on transportation. The logistics providers will also like need to ensure that they have leak-free transportation. So all potential hazards of having these type of fluids being in contact with the operators that are in the logistics and transportation providers so that they can operate in a safe environment. And recyclers of the IT hardware, they would also like need to handle the materials without any potential hazardous residue. So like in the guidelines that would come from this work stream, we are going to be addressing all of these needs by being able to offer to the end user a comprehensive list of all of the different types of techniques, solvents, and methodologies for proper cleaning, so that the operators or the data center holders can choose the proper technology, solvent, and methodology to perform cleaning on their IT hardware. So on the work that we've done on the work stream so far, we have already like seen or screened upon different existing methodologies. Here we tried more or less like to put them left to right from less scalable to like more scalable, right? We acknowledge that for POCs or demo deployments, for example, things like manual wiping might be efficient, but when it comes to trying to scale that up, that's really like not a thing, right? You would not be able to clean up thousands and thousands of servers on these massive deployments just by hand. Each one of these technologies might have like their own pros and cons, and yet again, one of the objectives from the workstream is just to gather all of this information so that the operators and the data center owners can make informed decisions on what is the best type of solution architecture or solvent that they could use on their potential deployments.
You do click. I'll pick up from here. You make the click. As with all the other work streams, our mission primarily is we are working on a white paper, as Romà said, and in our technical committee calls. We've got a team of experts in this space that we draw on and collaborate very closely with. It's a very high energy group. And here is where we pull in a number of different cleaning methodologies, as well as some pros and cons. The white paper draft would be we'll be almost 3/4 of the way through the first draft of this paper, and then that gets shared with the OCP community, you guys, for feedback and support, revisions, et cetera. And the last stage, we'd move on to publication stage. The one thing, I could move next one. On the next slide, one thing we wanted to be really clear on is the folks in our work stream is we're not putting out a checklist, so to speak, but a very comprehensive guide of methodologies that would work in this space. And the intent here is to just give guidelines around protection for worker safety, proper PPE that's required when handling certain cleaning solvents or dielectric fluids to ensure that no harm to the person, but also in our cleaning guidelines, we give you options that would be appropriate for the components or parts so that to avoid any etching or damage to these very sensitive and very expensive IT components. In the interest of time, this just reiterates the point that Romà made. What happens at the bench scale as you move to commercial deployment may not necessarily translate 100%. So a lot of the guidance and steer around ensuring the proper cleaning methodology is followed is absolutely critical to ensure that in deployment, at the deployment scale, that the parts are efficiently or precision clean where needed, particularly in regards to connectors and switches. Romà has mentioned already these four, we picked up 4 representative types of cleaning technology. The first could be a combination of manual cleaning, could sometimes be appropriate, but here that's generally very dependent on the user and can vary as that individual gets tired. So the level of cleaning may not be as consistent towards the end if you're handling a large number of parts. There's spray techniques as well, and here we recommend these. You'll see in our paper, we recommend these for, say, PCBs, but the spray must be impinged at an angle to avoid redeposition. The immersion dip tank is another pretty efficient method that now is more effective on parts that kind of have crevices or oddly shaped geometries. And the beauty of the immersion dip tank is that the fluid can, the cleaning solution, can get into these very deep crevices and solubilize and remove the contaminants in that way. Ultrasonic baths, a little bit more pricey, but this uses cavitation ultrasound to create microscopic bubbles that kind of impinge on and break through the surface tension and physically dislodge the contaminants from the parts. Vapor degreasing, we say here in our team, we talk quite a bit around this, but is a very efficient cleaning methodology, and here we're working very closely with the vapor degreasing vendor. Could be very, very important so that the solution matches and doesn't cause harm to the surface of the material. In the interest of time, coming back to where we are, green marks the spot with the white paper draft. We're preparing and we're ready for peer review when that comes, and eventually leading to publication of these various cleaning methodologies that are available and fit for purpose, as well as fit for scale in a commercial deployment.
So with that we have come to an end. It's the time for the call to action. We would encourage, with this couple of really short sentences. Like we are trying to shape like the standard, or like to name all of what's available. So like please shape the standard with us, secure the future for these type of technologies. As immersion cooling adoption accelerates, thousands of servers would eventually need to be decommissioned and therefore cleaned or returned for maintenance purposes. Without clear, scalable cleaning guidelines, the industry will lack standardized and a safe way forward. So we are still, welcoming every single person that would like to form part of this beautiful work stream that we have together. Our call schedule is each second Wednesday of the month at these times that you can see here on screen. Please feel free to scan the QR code, join the mailing list, join the work stream, and help us getting the paper out. Thank you for your attention.
Thank you.